Solving exponential functions by guessing. Solve the exponential equation. So this is asking the question, what exponent makes 5 into 125? So let's look at the 5s. What exponent makes 5 into 125? We see that the exponent is 3. So x equals 3. What exponent makes 10 into 100? X equals 2. What exponent makes 9 into 729? X equals 3. What exponent makes a 7 into 49? X equals 2. What exponent makes an 8 into 4096? X equals 4. Now what does a fractional exponent do? 25 to the 1/2 power is the same as the square root of 25, which is 5. 36 to the 1/2 power is the same as square root of 36, which is 6. 16 to the 1/2 power is the square root of 16, which is 4. Stop the video and figure out what 512 to the 1/3 power is. Step 1, change it to radical form. In this case, this is the cube root of 512. So we look at our chart of powers and we find in the cube column, because I want to take the cube root of a number, I find 512. The cube root of 512 equals 8. Now, using what we just went over, so what exponent makes a 25 into a 5? We just learned that an exponent of 1/2 will make a 25 into a 5, because an exponent of 1/2 takes the square root of 25. What exponent makes 243 into 7? Exponent of 3. So the cube root will make 243 into 7. What exponent makes a 9 into 6561? 4. So an exponent of 1/4 makes 6561 into 9. What exponent makes 49 into 7? Well, that's the square root, so that's the exponent of 1/2. What exponent makes 121 into 11? We recognize the square root again, so that's an exponent of 1/2. Next, what exponent makes 10 into 20? We can see that 10 to the exponent of 1 is 10. 10 to the exponent of 2 is 100. So we're going to guess numbers. So use the exponent button on your calculator. What is 10 to the 1.1? If we plug it into Desmos, we see that 10 to the 1.1 is about 12.5. 10 to the 1.3 is 19.9. If we play around with numbers in Desmos, we can see that x equals 1.301 is very close to the correct answer. How about the next one? 6 to what exponent gives me 1290? Well, if I look at the 6's, I can see that 6 to the 4th power gives me 1296. So let's guess x equals 3.7. Next, we're going to plug it into your calculator or use Desmos. 6 to 3.7 is 757. So play around with this a little bit more on your calculator and find a number closer than 757. By playing around with numbers in Desmos, I was able to see that 6 to the exponent 3.9974105 got me really close to 1290. But we need a shortcut. We don't want to have to guess numbers all the time. We need a function that will undo the exponential function. Now we know that if this was x squared, we would undo the squared function with the square root function. But if the variable is in the exponent place, we don't know how to undo that one. Introducing the log function. You've probably noticed on your calculator that there is a button that says log. The log function is a function that undoes an exponential function. And we're going to learn a lot more about log functions later. But for right now, if you need to solve for the exponent, then you say x equals log of the answer divided by log of the base. And that will give you an exact answer when solving for the exponent. So using the log function, we can see that x is equal to 1.3010 and so on, which rounds to 1.3. So if you do not know the exponent, you can use the log function to solve for the exponent. Let's try this one. X is equal to log of the answer divided by log of the base. So plug that into your calculator and see what you get. And that rounds to 3.99, which would actually round to 4, depending on what place we're rounding to. Now, there's a lot more to this. This is actually using the change of base formula, and we'll talk more about that later. But I just wanted you to see the need for the log function. We need a log function for times when we don't know the exponent and we're trying to solve the equation.